between frequency, wavelength, and velocity. The formula that relates the three terms together is V equals F lambda. This velocity equals to frequency multiplied by wavelength, which means velocity equals frequency multiplied by wavelength. From there, we have our velocity. We have another formula for velocity, which equals to distance traveled by wave over time taken. Distance traveled by wave over time taken. That is, the distance traveled by wave, as I said in the wave graph that we drew before, that the distance between two successive rests is what we refer to as wavelength. Then from there, you can say that V equals to wavelength all over T. Can I say V is the distance traveled by wave, is being represented by wavelength, and the time taken is represented by delta T. That's what brought us to V equals to wavelength over time, which is measured in meter per seconds. From there, we have from the definition of the frequency. Frequency is the number of complete vibrations or cycles that the particle makes in 1 second. And that is equivalent to the number of complete waves passing a given point in 1 second. And this it is R. The number of frequency F will be equal to 1 all over T, where F is the frequency, and T is the time taken. In other words, you can use this formula to derive a period. Period is the time taken by a wave particle to make one complete oscillation, and is measured in seconds. From this formula, by making T from the formula above, which is F equals to 1 over T, making T the subject of the formula in the formula F equals to I 1 over T. Going to be, we are going to cross multiply. You have F equals 1. When F equals 1, making T the solid formula, we are dividing both sides by that will be ft divided by equals 1 divided by f. From there we have t equals to 1 over f. T equals to 1 over f, which is measured. It is measured in circle. So let's now go for an example. Example here we are going to make use of the formula. Let's make use of example. The radio station broadcast at the frequency of 600 kilohertz. If the speed of light in air is 3 times 10 raised to power 8 meters per second. Calculate the wavelength of the radio wave. The radio station broadcast at the frequency of 600 kilohertz. If the speed of light is 3 times 10 raised to power 8 meters per second, you have to calculate the wavelength of the radio wave. Before you solve the question, you must first of all understand the question. So, if you look at the question, the first thing you have to do here is to write out the given parameters. And you give f lambda, that is v velocity, equals to frequency times frequency of wavelength. We should compute the whole parameters, the whole data given there into the formula. It's going to be 3 multiplied by 10 raised to power 8 equals frequency, that is value of our frequency, times wavelength. But we should look at the frequency here. The frequency is given in kilohertz. And in our previous page here, where we talk about the terms in wave, we said frequency is being measured in what? In hertz. It's not in kilo. But we made mention of hertz the other time. As the question is giving us the value of frequency in kilohertz, that shows we have to multiply the given value by 1000. That is, so that we can have the measurement multiplied by 1000. This is multiplied by 1000 will give us 600,000. This is the new value of our frequency. It is that new value that is going to be computed into the place of frequency in the formula. It will now be 3 times 10 raised to the power 8 equals 600,000 times wavelength. From there we have 3 times 10 raised to the power 8 equals 600,000 wavelength. Making wavelength the subject of the formula here, we are going to divide both sides by 600,000. Divided by 600,000 divided by 600,000. 600,000 will cancel out 600,000. we're going to be left with wavelength equals 3 times 10 raised to the power 8 all over 600,000. Writing this 600,000 in standard is going to be wavelength equals to 3 times 10 raised to the power 8 divided by 6 times 10 raised to the power 1, 2, 3, 4, 5. Count the number of zeros. It's going to be what? 6 times 10 raised to the power what? 5. From there, with the law of indices in mathematics, you can easily have it as wavelength equals 3 all over 6 multiplied by 10 raised to the power 8 minus 5. From there, you can have it as wavelength equals 1 all over 2 multiplied by 10 raised to the power 8 minus 5, which will lead us to 1 over 2 multiplied by 10 raised to the power 8 minus 5, that's 10 raised to the power 3. If you wanted to have it in decimal, 1 over 2 in decimal is going to be wavelength equals to 0.5 times 10 raised to the power 3. 0.5 in standard form is going to be wavelength equals to 5 times 10 raised to the power minus 1 times 10 raised to the power 3. With the law of indices, again, I'm going to have it as wavelength equals to 5 times 10 raised to the power minus 1 plus 3. Minus 1 plus 3 will give us wavelength equals to 5 times 10 raised to the power 2. And the unit is going to be meter. That's the wavelength. That's what we have to find. The wavelength of the given question.